From the absolute tiniest atom to the biggest galaxy you can imagine. Everything, and I mean everything in the universe is constantly on the move. So, how do we make sense of all this cosmic chaos? Well, that's the puzzle we're going to piece together today, starting with the very basics of motion. It's a wild thought, right? That chair you're sitting on, the air you're breathing, even the atoms that make you, well, you, it's all a massive storm of activity. It turns out absolute stillness doesn't actually exist. It's kind of the one constant rule of the whole cosmos. And that really is the million-dollar question. How do we even begin to describe, predict, and understand this universal dance? To do that, we need a language, a specific set of rules and terms that physicists came up with to turn all that chaos into something we can actually wrap our heads around. So let's start learning it. Okay, so before we can get into the how or the why things move, we first have to agree on the what. What does it really mean for something to be in motion? The answer, believe it or not, is way simpler and a whole lot more powerful than you might think. And there you have it. It sounds almost too simple, doesn't it? A change in position over time. But this one little idea, it's the bedrock for literally everything else we're going to talk about. Every single calculation for a planet's orbit or a speeding car, it all starts right here. Now, this is a really crucial split in how we approach movement. Think of it like this. Kinematics, that was Galileo's thing, is like the crime scene investigator. It's all about meticulously describing how everything moved. The speed, the path, the timing. But dynamics, Newton's world, that's the detective asking the big question. Why did it move in the first place? What was the unseen force that caused it all? Okay, so we've established that things move. But, the motion of a spinning top is obviously different from a car driving down the street. To get a handle on this, physicists have sorted all of this beautiful chaos into four main categories. First up, the one we all know best is translational motion. This is just the simple act of getting from point A to point B. It doesn't matter if you're a car on a highway or a baseball flying through the sky. The entire object moves together as one unit. But what if something moves without actually going anywhere? Well, that's rotational motion. Think about the Earth spinning on its axis, or the blades of a fan whirling around. Their overall location isn't changing, but they're definitely in motion. Then we've got that rhythmic, back-and-forth movement of oscillatory motion. You see it in a pendulum's steady swing, or you hear it in the vibration of a plucked guitar string. It's just a constant, predictable repetition around a central point. And finally, we get to the beautiful chaos of random motion. This is the totally unpredictable zigzag of smoke particles swirling around in a sunbeam or gas molecules just bouncing all over a room. There's no set path here, just pure, energetic freedom. So, we know how things move, but that just brings us right back to the why. What is this invisible thing that starts, stops, or changes motion? The answer is one powerful, simple word: force. And this quote just says it all, doesn't it? This is Newton's first law of motion, and it was a total game changer. It tells us that things don't just start moving for no reason. Nope, they need a push or a pull, an unbalanced force to get going. And these forces pretty much come in two main flavors. First, you've got the ones we deal with every single day, contact forces, where you literally have to touch something to make it move. But then you get the really weird stuff, force fields. These are the invisible, almost mysterious forces, like gravity and magnetism, that can reach out across empty space and pull things together without ever touching them. All right, get ready for a truly mind-bending idea. It turns out that motion isn't absolute. How fast something seems to be moving depends entirely on where you're watching it from. It's all about your point of view. So let's make this super clear. Imagine you're on a bus and it's cruising along at 60 kilometers per hour. Now a car zips past you at 100. To you, on the bus, it doesn't really seem to be flying by, right? From your point of view, your reference frame, its speed is just the difference. A much slower 40 kilometers per hour. Your motion literally changes how you see its motion. It's all relative. And finally, let's talk about a really special but super common type of motion, moving in a circle. Because, as it turns out, it has its own unique set of rules. We call this uniform circular motion. Now, the key thing to really get here, and this is a big one, is that even if an object's speed stays the same, its velocity is not. Why? Because its direction is constantly changing, and any change in velocity means it's always accelerating, pulling towards the center of that circle. So what's keeping it moving in that circle? A real, actual, inward pulling force called centripetal force. Now, that feeling of being pushed outward, what a lot of people call centrifugal force, that's not a real force at all. It's just your body's inertia, its natural tendency to want to keep going in a straight line. The only real force in this situation is the one pulling you in. So let's pull all that together. Here's your brand new toolkit for understanding motion. At its very heart, motion is just a change in position, and we study it with kinematics, the how, and dynamics, the why. It comes in 4 flavors, from straight lines to complete chaos. The engine behind it all is force, and most importantly, always remember that motion is relative, and circles are only possible because of a constant, real force pulling everything inward. Which leaves us with one last thought to chew on. You probably feel like you're sitting perfectly still, but the Earth is spinning, and it's orbiting the sun, and the sun is rocketing through the galaxy. So the real question is, relative to what exactly are you moving right now? Something to think about.